Hello. In this discussion, we are going to discuss thinking. We're going to define what is thinking. How do we do it? Before we begin, I would like to talk about a few of our objectives for this discussion. First and foremost, we want to define the terms cognition and thinking, describe how mental images and concepts are involved in thought processes. Second, we want to approach this from a neuroscientific perspective. So what goes on in the brain during perception and mental imagery? Okay, we want to talk about the certain brain areas that are involved in perceiving the faces and places. Okay, and last but not least, we want to also discuss, how do we form concepts? And we want to be able to differentiate between natural concepts and formal concepts and explain how prototypes and exemplars are used. We will discuss all this in detail together, so just relax and here we go. All right, so first and foremost, we want to discuss and we want to define what thinking is. And so, this is a key theme. We want to always understand what is thinking. Why are we even talking about it? Okay, so thinking is a broad term. It refers to how we use knowledge to analyze situations, to solve problems, and make decisions. So keep in mind that I kind of highlighted that term how, and I underlined it, and that's because we can't talk about thinking without discussing how we use our knowledge. First and foremost, we also want to understand, we use that knowledge to think analytically. Okay, we want to be able to analyze what's going on in this situation. And then we want to be able to solve the problem after we've analyzed it. And last but not least, our goal is hopefully to be able to make decisions based upon that analytic process. Okay, so for some definitions here, I have highlighted in red font some important terms that I want you to focus on. So feel free to pause the video, think about these, as well as possibly taking notes on these. So the first term that I have highlighted is cognition. So that is mental activities that are involved in, acquiring, retaining, and using knowledge. So cognition is basically our mental processes. The second term on this slide is thinking. And we've already talked a little bit about this, but here's a little more of a formal definition. So this definition says thinking is the manipulation of mental representations of information in order to draw inferences and conclusions. So we want to be able to manipulate, we want to use the mental representations that we have obtained of information and then hopefully eventually, make sense of the mental representations as well as to use those to aid us to draw conclusions. So some of the basic building blocks of thought are mental images. You can see that in red font here. And so mental images, basically that just involves the manipulation of two forms of mental representations, as you can see that here. The first of those is what's called mental images, and the second is concepts. So mental images are basically pictures. Images are pictures. And so we have to keep in mind we are talking not only about being able to see an image, but to imagine an image. So keep in mind here that the second thing that's on the slide says, well, people, they can also form mental representations that involve senses other than vision. So we have to keep in mind that there's a little more to our representations than just visual images or mental images. We will discuss that a little further as we proceed in this course. Before we go on to the next slide, I would like to point out some things that I have added to this. It says mental images, they are manipulated in the same way that visual images of actual objects are manipulated. So even in our imagination, we can manipulate visual images, mental images, the same way that we can manipulate the incoming visual information through our sensory experience. And so this is demonstrated by, well, being able to manipulate, when we're imagining, when we are imagining an image, we can actually manipulate it. We can scan it, and rotate the image. We can do whatever we want with it. So a good example might be, we're thinking about our favorite pet. Take, for instance, for those of you who like pets, all right? And so I'm thinking of a cat. And so as I'm thinking about that cat, I can view it in my mental image. I can view it from the front. I can look at its face, or I can look at it from above. I can actually kind of rotate that image in my mind, or I can look at it from behind. I can see its tail, etc., etc. So just keep in mind, once you bring up a mental image, you can rotate it and scan it in any way whatsoever in your imagination. Continuing from that concept, we also want to talk about concepts. So what are concepts? And those are a mental category of objects or ideas based on shared properties. So things, that it's a form of a mental shorthand that economizes our cognitive processes. So keep in mind, concepts. We form concepts, through basically learning attributes of certain categories. All right, and so the next term I'd like to discuss is prototype. You can see that in red font here. So a prototype is, well, the most typical instance of a particular concept. Going just a little bit further, another term that I'd like to make you aware of is exemplar. And an exemplar is basically an individual instance of a concept or a category. So it's an individual instance, and that's usually what we hold in our memory. Okay, let's proceed. So here is right here our a definition of mammal. Okay, so here is a formal definition of mammal. It is a warm-blooded vertebrate animal of a class that is distinguished by the possession of hair or fur, the secretion of milk by females for the nourishment of its young, and typically the birth of live young. Now you see in certain types of font here, I did do italics and things of certain things I wanted to make you aware of, So possession of hair or fur, secretion of milk, and birth of live young. Okay, so that is right there. That, as we are looking at that definition, we are forming a concept of what a mammal is. So you may be thinking, well, okay, what does this have to do with our discussion about thinking, especially in regard to psychology. Well, let's go on to the next slide. So we've got a conceptualization of what mammals are. So are these mammals right here? I included some images right here. So this is a bat. Okay. And this image right here is something that's pretty uncommon. This is an African long-tailed pangolin. Okay. Now, do you think those are mammals? Feel free to pause the video if you like. Now, because those are, they do not, fit our prototype for a mammal, okay, it takes us longer to decide whether they belong to the category mammal than it does to classify animals that are closer to the prototype. So it just takes us a little bit longer to decide whether those actually belong to the category mammal. Okay? Because they may not fit our first conception, the prototype conception. Okay, approaching this from a neuroscientific perspective, we want to talk about now, well, when we see images, faces, and places in our mental imagination or our mind's eye, there are certain areas of the brain that are activated. So in both vision and imagery. So brain imaging techniques, those usually have shown us that when we look at a face or even imagine one, that image is actually processed in what is called the fusiform facial area, or the FFA. Okay, so I put that in red font so you could, I highly recommend that you put that in your notes, the fusiform facial area. That is the part of the brain that is activated basically when we look at a face or even imagine one. So you can see right down here, okay, so this is imagery right here. Okay, the top row right here is the participants when they're actually seeing a face. Okay, and you can see certain parts of the brain are lighting up. They are becoming activated. And then we will look down below here at the second row right here. On the lower left, you can see the same parts. This is when the individual is actually imagining a face. Okay. So you can see similar parts of the brain are being activated, even in the imaginative process. And same thing with actually sensing and perceiving an actual location or place. That is in the upper right-hand row of this set of images. Okay, you can see these parts of the brain lighting up. Okay, and so those parts of the brain that light up, you can see those are different from the fusiform facial area, thinking about faces or actually perceiving faces, sensing and perceiving actual faces. Well, right here on the upper right-hand part right here, this is the parts of the brain that are being activated when they are seeing or imagining an actual location or a place. Okay, down at the lower right-hand row right here, this is when the person is actually imagining a place. And you can see that similar parts of the brain are actually being activated. So, the parts of the brain that are being activated when we imagine or even look at an actual place, that is what's known as the parohippocampal place area, the PPA. All right, proceeding from there, we're going to talk a little bit more about looking into, well, when it comes to human thinking, solving problems and making decisions are two activities that are very key in human thinking. Okay, so it's important to keep in mind that problem solving, that refers to thinking and behavior directed toward attaining a goal that is not readily available. So there are different problem-solving strategies that we can employ. And so we're going to take a look at, what are some advantages and disadvantages of each problem-solving strategy that we're going to take a look at. Once again, feel free to pause the video and think about this or make notes and be prepared to discuss this if we are in class together. Okay, other approaches to problem solving are using our insight. Okay, we can see that down here at the very middle of this left-hand side of the slide. Okay, and how does intuition work? And how are those different from one another? We're going to take a look at that going forward. And at the very bottom left-hand side of this slide, we talk about some issues like functional fixedness and mental set. And how do those interfere with problem solving? How do those processes interfere with problem solving? Let's proceed. So we talked about problem solving strategies, and I said there are a variety of them. And so I put those in red font here, and I would like to talk briefly about each one. So trial and error at the very top. Well, we try a variety of solutions and eliminating those that don't work. Kind of makes logical sense. The second problem-solving strategy is algorithms. And that's when we use basically a specific rule or a procedure or a method that inevitably produces the correct solution. The third type of problem-solving strategy is what's known as heuristics. So heuristics is basically when we follow a general rule of thumb to reduce the number of possible solutions. So we're narrowing it down. If you've ever heard that phrase, let's narrow this down. Well, basically we are starting to narrow it down into a heuristic. General rule of thumb to reduce the number of possible solutions. All right. And then, so some examples I put down at the very bottom here. Some of the useful heuristics are like, well, breaking a problem into a series of sub-goals. Kind of like an outline process. Another useful heuristic is working backward. Okay, so working from the solution and then working backward toward the problem in order to solve the problem very efficiently. Okay, so let's get some definitions here. We want to understand, I mentioned a little bit before, I said we can actually use insight and so insight basically involves a sudden realization of how a problem can be solved. So keep in mind, insight, I put that right here in italics, that is sudden realization. The second type of problem-solving strategy we want to look at is intuition. Okay, and intuition is defined as, well, that's when we come to a conclusion or make a judgment without conscious awareness of the involved thought processes. So we use our intuition. We just like, hey, I can't explain it. I just feel that. I just know this inside of me. That is intuition. And you can see it's a little different than just a sudden realization. It's just something you feel that you've always known or that has made sense to you. So that is the difference between intuition and insight. So when we were discussing intuition, for those of you who would like to gain a little more insight into the nature of intuition, there are a couple stages of intuition. There is the first stage, which is called guiding. And basically that's when the pattern of information being considered is unconsciously perceived. So we're just not aware of it. We're not thinking of it yet. But once we are able to start putting the information together, and then we actually achieve that aha moment, that is the actual second stage. And that is what's called the integrative stage. That's when we put it all together in order to arrive at that moment of intuitive type process or result. And I like to refer that to as the aha moment. We just go, I get it now. And that is representation of the pattern. That's when it becomes conscious, usually as a hunch or a hypothesis. All right, let's go forward here. So I want to introduce you to a couple more terms, because when it comes to thinking, well, we have to think about it in depth, and no pun intended. All right, so the first term we're going to look at here is what's called functional fixedness, and these are obstacles to solving problems, okay? So functional fixedness, well, that refers to the tendency to view objects as they functioning only in their usual or customary way. Hence, the function of that object is fixed. It only functions and only works in the usual way that it usually does. Hope that makes sense. Now the problem is approaching it like saying, hey, this only works in this one way. I only understand this, or I've only thought of it in this one way. Well, that prevents one from seeing the full range of ways in which an object can be used. So you can see from this imagery right here, as people are using, plastic bottles in a different way than than we usually conceptualize them and view them as being used in a certain way or a customary way. So what do we do when we want to overcome functional fixedness? Okay, so basically we find new uses for familiar objects. Okay, and so we start to expand, looking for the full range of possibilities. All right, we're going to talk briefly about another obstacle to solving problems, and that is having a mental set. So the mental set, that just refers to the tendency to persist in solving problems with solutions that have worked in the past. So those of you who have said to yourself or said to another, or someone has said to you, that's how I've always done it. And so that's why I'm doing it this way. Well, that is indicative of the fact that they are employing a mental set. So you can see right here, that can prevent seeing other possible solutions, especially in areas where one is knowledgeable or well-trained. So when one is knowledgeable or well-trained, they tend to become a little more relied upon their mental sets. Okay, going forward here, we're going to switch gears just a little bit. Another important part of thinking, the thinking process, well, we always want to look at our decision-making strategies. So how do we make decisions? How do we go about making those decisions? Do we have an efficient approach that works for us? So we want to keep in mind that we tend to employ what's known as cognitive strategies, okay, and they are used when making decisions depending on the type and number of options available to us. So basically, we are using what we've got in order to hopefully make a decision. Doing our best with what we've got. So some questions, to think about if you pause the video and think about these, or, review this video and think about these questions. So what are the single feature models? The additive model and the elimination by aspects models of decision making. So you can see there are 3 models of decision making that we're going to take a look at. And we also want to, as we look at each one of those models, we want to talk about, well, under what conditions does each strategy function most appropriately? Last but not least, we want to think about the question, well, how do we use the availability and representativeness heuristics to help us estimate the likelihood of an event? So more than likely this is going to happen. So how are we using either the availability or representative heuristics to help us answer that question? So let's first come up with some definitions of each of those strategies for decision making. So the first one is the single feature model. So that's when we make a decision by focusing on only one feature. The second strategy is the additive model. That's when we systematically evaluate the important features of each alternative. Okay, so we want to actually evaluate the pros and cons of each alternative in order to help us make it, hopefully, a helpful decision. The third decision-making strategy we'd like to talk about is the elimination by aspects model. And that's when we basically rate choices based on features. We eliminate those that do not meet the desired criteria despite other desirable characteristics. So we use the elimination by aspects model in our thinking processes, or especially the decision-making strategies. Well, we use that model when we actually throw it out if there's something that doesn't meet our criteria, even though there might be other good positive characteristics about it, but we just tend to automatically throw it out, say, hey, this doesn't work. Let's go forward here. So we're going to take a look, so we've got the availability heuristic right here. And so these are the decisions involving uncertainty, estimating the probability of events. Keep that in mind. So we use the availability heuristic, and I underlined this because this is the important part. So basically that heuristic is the probability of an event is judged by how easily previous occurrences of that event can be recalled. So when we tend to basically come to a decision, making a quick decision about something. And we did it because, well, how recently we actually witnessed or experienced that occurrence. Well, that is the availability heuristic. Okay, let's go forward here. So, looking at the availability heuristic, take for instance when we see this image right here of a shark in the water. So, why are people, afraid to go to the beach after a well-publicized shark sighting? Well, that's because that was the most recent conversation that they have engaged in, and so, hence they use that heuristic in order to make the decision like, hey, I'm not going to go to the beach. There are sharks there, and I saw that on the news or something of that effect. Okay, now we're going to talk about the representativeness heuristic, and that basically refers to the likelihood of an event is estimated by comparing how similar it is to the prototype of the event. Okay, so how similar it is to what ordinarily happens, the prototype of the event. Now, that can be a little faulty because, well, it's, when we estimate using the representativeness heuristic, that actually means that we possibly are not using the prototype variations, or they're not considered very accurately. Okay, so let's proceed. So here's a question, so when contradictory evidence can actually strengthen a person's established beliefs, why does that happen? Okay, so feel free to pause and think about this and come up with an answer, and be sure and research all the different heuristics and why that may happen. So that ends our discussion of the topic of thinking. Good luck, and we'll see you on the next discussion.